Welcome back to Akime Academy. Today we are trying to look at the concept of sets. Okay, the concept of sets. Surd is an interesting topic, but most students frown against it. Okay, they always frown on it because they don't have the concept of it. Now, by the end of this lesson, you are going to see surd and smile on it, and even wish for more. Okay, so let's look at surd. First of all, let's take this into consideration. Okay, let's take note of these three items. Surds are irrational numbers. 1. Okay, surds are irrational numbers. 2. When you convert them into decimals, they are non-terminating. Okay, so it does not end, it goes on and on and on. 3, they are not repeating. Okay, when you convert them into decimals, they are not repeating. Okay, good. So how can we determine surd? How can we know that this particular number of value is a surd? Now we can do that, or we can know surd whenever we see or realize that there is a non-perfect square number inside a radical sign. Okay, surds can be noted or seen whenever we see a non-perfect square under a radical sign or a square root. What are these non-perfect square numbers? Okay, so let's look at the perfect square numbers. To know perfect square numbers, the only thing you have to do is start your counting numbers. I hope you are all aware of counting numbers. Numbers from 1, okay, 2, 3, let's maybe 15, 16, and goes on and on and on forever. Counting numbers. Now, the squares or the results of the squares of these counting numbers are numbers we term as what? Perfect square numbers. Okay, let me take it again. The results of the squares of these counting numbers to infinity are what we term as what? Perfect square numbers. So when we square these numbers, so 1 square, then we have, okay, so 1 square will give us 1, okay, 2 square will give us 4, 3 square 9, and this one goes on. We can find the rest. So we have 15 square, which will be 225, okay, as well as 16 square, which is 256, and goes on and on and on. Okay, so these numbers over here are the numbers we term as what? Perfect squares. Okay, they are numbers we call perfect squares. They are perfect squares because when we find this one, or whenever we put these numbers under a radical sign, we can get an answer to it, a straight answer. Okay, so these numbers are what we term as what? Perfect squares. Now, the numbers apart from these numbers, the rest of the numbers are what we term as what? A non-perfect square numbers. And anytime we see these numbers under the radical signs, then these particular numbers become what? The surd. For example, 5, we don't have 5 here, so 5 is a non-perfect square. And therefore, whenever we have a radical sign, over 5, then this value over here becomes what? A surd. It's an irrational number. Okay, good. So when we convert this value here, which is root 5, into decimal form, then we are rest assured that we are going to have a number, or we are going to have a decimals, which are what? Non-repeating and also non-terminating. Okay, That is why we call it surd. I hope we are okay with the explanation over here. Good. So after this explanation, I hope you can give yourself series and series of examples, okay, and surd, or numbers which are qualified to be surd. Okay, that's good. Now let's move on to the next steps. Here we know that numbers, okay, numbers that are what? Not perfect squares are termed to be non-perfect squares. And whenever these numbers are under a radical sign, we call these numbers irrational numbers, and they are also known as surd. Okay, good. Assuming, let's take some few examples over here. So we have root, let's say root 18. Okay, root 18. I don't think we can have 18 within the perfect numbers over here, the perfect square numbers. Okay, because none of the counting numbers over here, or none of the square of the counting numbers over here will give us 18. Okay, therefore 18 over here, square root of 18, is an example of what? A non-perfect what? Square. Okay, and square root of 18 qualifies to be what? A surd. So in this case, what we do is, whenever you have a number like this, we have a way of doing it. Okay, instead we don't add numbers when they are in big terms like this. Okay, numbers when they are in big terms. So what we do is we try to reduce the number within the radical sign. We try to reduce it down to its lowest form. Okay, so what do we do over here? Here we ask ourselves, do we have a number which can be a perfect square and an imperfect square, which we can multiply to get the number under the radical sign, which is 18? Is it possible? Yes, I think it's possible, because we have 9. 9 is a perfect square number, okay? And 2, which is an imperfect square number, or non-perfect square number. When we multiply these two numbers, we get 18, okay? So in this case, we can reduce this one by having one perfect square number, okay, and another non-perfect square number. So at this point, then we can split this one as square root of 9 multiplying square root of 2. Okay, then at this point we know that square root of 9, because 9 is a perfect square number, we can get a value for it. We can get an answer for it, okay, an accurate answer. So in this case, square root of 9 will give us what? 3. Okay, times, because 2 is a non-perfect square number, we can find the square root of a non-perfect square number. Therefore, we maintain it like that over here. Okay, so at this point, we multiply them. Now, this is a rational. Okay, it has given us a rational number, a number which has no square root. And this one is what? A surd, a number covered with a square root. Therefore, we can multiply this rational number by the number inside. So what we do is, there's one sitting here, which we normally don't write. So we can multiply the 3 by the 1. So at the end of the day, we are going to get 3 times 1, which will be 3. So you have 3 root 2. And this becomes your final answer in terms of this particular program, where you are asked to simplify it. Okay, this becomes the final answer, because at this point we can add these two. We cannot also multiply them because they are not the same. So this is a rational number, this is an irrational number. So you leave them in this form. Then at this point you can say that you have simplified square root of what? 18. Let's look at the next example, which is square root of 24. Okay, we use the same principle over here. So square root of 24, we look out for one perfect number, and also another non-perfect number. Okay, so if you look at 24, we are going to have 4 times 6. Okay, so 4 times 6 will give us 24, which is the same. So from this point, we can split them and have root 4 multiplying root 6. Okay, so we know that 4 is a perfect square number. Therefore, square root of 4 should give us a straight answer, which is 2 times square root of 6. 6 is a non-perfect square number. Therefore, we can find the square root of it. Then it remains Z. Okay, it remains Z. So here we multiply 2 times root 6. 2 is a rational number. Root 6 is an irrational number. Okay, so the only thing we can do over here is that there's one sitting here, or there's one here, which is a rational number, but we normally don't write it. So we can multiply the 2 by the 1. Okay, so that we have 2 root 6. So this becomes the simplification of root 24. Okay, good. Let's look at the last example. Let's take root let's say 75. Okay, if you are to simplify this, the same principle, we look out for one perfect and one non-perfect in its lowest form. Okay, so here I think we can have 25 times 3. Okay, because 25 times 3 will give us 75. Then we can go ahead and split it. Okay, to have 25 here times root 3. Because 25 is a perfect square number, square root of 25 can give us a straight answer, which is 5. Okay, times root 3. Now this 5 is a rational number. It has no square root, and that's why you can see there's a square root here, and therefore we can multiply the 2. Okay, we should take note of it. We can multiply these 2 because they are not the same, or they are not in the same form. Okay, so what we can do is multiply the rational number by the rational 1 over here, which we normally don't write, so that we'll be having 5 root 3 as our final answer. At this point, there's nothing we can do with this thing. So this is the simplest form of root 75. Okay, use this method with different examples. Okay, give yourself different examples and use this method to simplify them. This brings us to the end of part 1 of Surds, and our next episode will be the part 2 of Surds. I hope this one helps. Don't forget to subscribe, okay, so that you can be the first to get the part 2 of Surds. As I just said, at the end of this lesson, I believe you are going to see Surds and laugh at it. Okay, and if you have any concern or if you have any problem, leave your comment under the comment section. Okay, and I'll address it for you. Okay, so have a nice studies and do more examples. Thank you.